So the rest of learning target 9 is cosine, and not going to go through the whole thing. I'm going to just show sine. Okay. If you look at the unit circle, cosine and sine have similar values. So cosine is also going to be a periodic function. It's also going to make a wave. All right, it's going to be a curve. And if you look at the points at 0, pi over 2, pi, 3 pi over 2, and 2 pi like we did yesterday, those are also still the places for the maximum and minimum values and the x-intercepts for the cosine curve too. So today when I graph it, I'm just going to graph those. And we'll go through one specific interval. I'll try to clear some things up for you. Okay. So for cosine, we're still going to use those 4 points on the unit circle. So for cosine, at 0, cosine is, right? So in this case, our graph, we're going to start 1. At pi over 2, sine is 0. At pi, negative. I think you see how this is going now. At 3 pi over 2, cosine is 0. And at 2 pi, cosine is 1. All right, so that is the basic cosine curve. If I graphed sine on the same graph, sine would look like this. But you can see that sine and cosine are just shifted. Like one's just the shift of the other. So it's the same points. So the maximum and the minimum are still 1 and negative 1. So that means the range is still from negative 1 to 1. The domain, still all real numbers. 1 period, so 1 repetition is every 2 pi still. Okay, so the homework tonight's going to be the exact same. You have to create the interval that I want you to create. So the only thing that's different that I'll make, again, I made sine hopefully a little bit easy yesterday by saying the x-intercepts are all like the pi's, right? For cosine then, the x-intercepts are all the pi over 2 times n's. So the x-intercepts are all the halves. I should shift it over a little bit. Questions about where I got those points on this graph? Or anything I've said yet today? All right, so then on your note sheet, it says to graph, and it actually says on your note sheet, what, 11 pi over 2? So 15 pi over 2? Is that what it says? Okay. So if we're going to graph that, we're going to use, again, those every half as our hash mark. So 11 pi over 2. The next one would be 12 pi over 2, which is 6 pi. 13 pi over 2. Next would be 14 pi over 2, which is 7 pi. And then 15 pi over 2. So for cosine, all the x-intercepts are at all the halves, the pi over 2s. Any questions about what I've done so far? So the only thing I need to do is use the unit circle to figure out what's happening at 6 pi or 7 pi, so I know when it's increasing, when it's decreasing, right? When is it 1, when's it negative 1. So if you use your unit circle, start at 0. You go all the way around once, you hit 2 pi. Go all the way around again, you hit 4 pi. Go around again, you get 6 pi. Cosine is 1. And so that means at 7 pi, which is a half of a rotation, we'd be at negative 1. questions about that? All right, the last 3 questions on your homework assignment, preliminary target 9. Say, is the curve sine, cosine, or neither of them? Okay, so they're going to give you some curve, and you have to decide. So this is what the easiest way to figure out if it's sine or cosine is to look at the x-intercepts. That's the easiest way we've done it so far. So that's what we're going to look at. So remember that sine x has x-intercepts at all of the pi's, and cosine x has x-intercepts at all the halves. Again, where n is just some integer. So if you're looking at this curve on the screen, where are the x-intercepts? But they're not at every single one. They're at every other one, right? So this is neither sine or cosine. If it was sine, we'd have to have an x-intercept at every single pi, right? But that does not have that. Now, here's the thing. This could very well be a sine or cosine curve, but it is not y equals sine x or y equals cosine x. It could be transformed some way, like stretched out or something, and that's not what it's asking. It's just asking, is this the basic sine curve or is this the basic cosine curve? And this one is not. Okay? In the next few learning targets, that's what we're going to be doing. We're going to be messing with some things about sine and cosine. Okay? Questions at all, though, about anything we've talked about today or yesterday that I can go over right now? All right.